In this video, we'll talk all about the 5-number summary. We'll learn how the 5-number summary can be used as a measure of spread, how we can detect outliers using the 1.5 times IQR rule, and how to construct a box plot. First of all, the 5-number summary is another way to see how the observations in a data set are distributed. Like the name implies, there are 5 numbers in the 5-number summary. There's the minimum, Q1 or the first quartile, the median, Q3 or the third quartile, and the maximum. The 5-number summary divides the data into 4 equal parts, hence why we use the term quartile to describe some of those numbers. And in each section, it contains 25% of the data. So between the minimum and Q1, we have 25%. Between Q1 and the median, we have another 25%. The median in Q3, another 25%. And Q3 and the maximum, another 25%. So because of that, we can also refer to the first quartile as the 25th percentile of the data. And similarly, the third quartile is also the same as the 75th percentile. Remember that a percentile tells you what percent of the observations are below you. So the value for Q3 would say, okay, 75% of the observations were below whatever Q3 was. To find the 5-number summary, to compute it, it's very similar to cutting a candy bar and sharing it with 4 friends. That's essentially what we're doing with our data. We're going to be dividing the data into 4 equal parts. When you have a candy bar that you want to share with 3 of your closest friends, the first thing you would do is cut the candy bar in half, and then you would cut each half in half so that you have 4 equal parts. We're going to do the same thing with our data, starting with cutting the data in half. So to look at this, we're going to look at this little sample data set here. These are responses to a question that I asked some of my students, which was approximately how far do you live from campus in miles? And these are the responses that I got. So the first thing I want to do, like I mentioned, was cut the data in half. And I do that by finding the median. So I take my data and I'm going to order the observations from smallest to largest. Then, to locate the median, I work my way in from both sides until I get to the center. If I have an odd number of observations, then when I get to the middle, there's only one value, and that value is my median. Now, that's what happened here, but if I would have had an even number of observations, then when I work my way in, there's 2 numbers in the middle, and we take the average of those middle 2 numbers as the median. So in this case, 6 is my median. All right, now I'm ready to cut each half in half. And that's how I find my Q1 and my Q3, my first quartile and my third quartile. So I cut the data right in half at the median. Because I had an odd number of observations to begin with, I want an equal number in both halves of the data here. So the value of the median, 6, is not going to go with either side. That way I have 4 observations in each half of the data set. If my number of observations would have been even, then I could evenly divide them into 2 groups and there wouldn't be any leftovers. So all the observations would either be in the lower half or the upper half if there's an even number. But in this case, there was an odd number, and the odd man out doesn't go with either side. So to find my first quartile, I'm going to look for the median of the lower half of the data. As you can see, I've got these 4 observations here. When I work my way into the middle, because I have an even number, there's 3 and 5 that are in the middle. So I'm going to average the 3 and the 5 to come up with my first quartile. So Q1 is 4, the average of 3 and 5. Now I'm going to do the same thing with the upper half of the data. Q3 is the median of the upper half of the data. So working my way in from both sides here, I end up with 9 and 15 in the middle. So I'm going to take the average of 9 and 15, which is 12, and that is going to be my third quartile. The other two numbers of our 5-number summary, the minimum and the maximum, are the easy ones. The minimum is just the lowest number in the data set, and the maximum is just the highest number in the data set. So now I have my 5-number summary, which gives me an idea of where the data lies in this distribution. A couple of ways that we use the 5-number summary to measure spread are by looking at the range. And the range is just calculated by taking the maximum value minus the minimum value. We also like to look at the interquartile range, or the IQR, and that's computed by taking the value of Q3 minus the value of Q1. So for my data set, here was my 5-number summary. So remember, this is minimum, Q1, median, Q3, and the maximum. So to find the range, I take the maximum, which is 35, minus the minimum, which is 3, and that gives me 32 for the range. And my IQR is going to be Q3 minus Q1. So Q3 was 12, Q1 was 4, so my IQR is 8. The range is obviously going to be affected by outliers, because if there's outliers, then the min or the max would be an outlier, or maybe even both of them would be outliers. So oftentimes that's why we like to look at the IQR, because it is not as affected by outliers, because we're just looking more into the interior of the data. And the IQR tells us, okay, the middle 50% of the data had a spread of 8 values. Another way that we can use the IQR is to help us detect outliers. So here's my original data set, and looking at these numbers, then we probably would think that maybe 35 is an outlier, but what about 15? I mean, 15 is still quite a bit above 9. Sometimes it's hard to figure out where's the line, like how do I decide if something is an outlier or not an outlier. So this 1.5 times IQR rule can be really helpful for kind of drawing that line and saying, okay, above this value is an outlier, or below that value is an outlier. So here's our 5-number summary again for reference. So what this rule says is that we're going to call a data value an outlier if it's less than Q1 minus 1.5 times the IQR, or if it is greater than Q3 plus 1.5 times the IQR. So remember, the IQR was that thing we just calculated previously. That was the Q3 minus the Q1, that value. So if we just take the values from our data set and plug those numbers in here, it's going to give us those cutoff values for if we have values, data values that are outside of that, we're going to call those outliers. So let's do that for this data. So just for your reference, remember we already calculated the IQR to be 8. Okay, so I'm going to take Q1, which was 4, minus 1.5 times the IQR, which was 8. So that gives me 4 minus 12, which gives me negative 8. So I'm going to consider a value to be an outlier if it is below negative 8. Now, looking at my data set up here, clearly there's nothing that is less than negative 8. And in fact, since we're talking about miles away from campus, we can't get a negative value. So we have no low outliers in our data set. Now let's look at the upper side. We're also going to consider a value to be an outlier if it is greater than Q3 plus 1.5 times the IQR. So I'm going to plug the values from my data set in. So I have 12, which is Q3, plus 1.5 times the IQR, which is 8. So that ends up being 12 plus 12, which is 24. All right, so I'm going to consider something to be an outlier if it is more than 24. So again, I'm going to look back at my data set here. And did I have any values that were greater than 24? Well, yes, I did. 35 was greater than 24, so we will consider that to be an outlier. So that's how we can use that rule to help us determine if we have outliers in our data set. The last thing that I want to talk about with regards to the 5-number summary is a box plot. A box plot is just a graphical look at the 5-number summary. And to construct a box plot, we can follow these simple steps. So first, we're going to draw a numerical scale that's appropriate for the data. So we're just setting up our axis. And a box plot can actually either go horizontal or vertical. It's kind of a personal preference, or however if you're doing it on the computer, however your software program does it. Then we're going to draw a box that stretches from Q1 to Q3. Divide the box with a line at the median. Then we're going to draw a line from Q1 down to the lowest non-outlier point, and then from Q3 up to the largest non-outlier point, and then finally we're going to represent our outliers with an asterisk. So let's see how we would do that for this data. It makes a lot more sense once you see it visually. So here is my data set, and here is the 5-number summary. So I'm going to start by, first of all, I've already got my axis set up down here, and I just made it on a scale that I knew would be able to include all the values in my 5-number summary. All right, so I'm going to start then by drawing a line for Q1. So Q1 is 4. So I draw a line here that corresponds to 4 on my axis. Now I'm going to draw another line for Q3. So Q3 was 12, so now I've drawn a line at 12. Then I connect those lines to form my box. Okay, next I'm going to divide the box at the median. So my median was 6, so now I'm going to draw a line in there at 6 to represent the median. Okay, now I've got the middle 50% of my data represented. Now I'm going to draw a line from the bottom of my box to the smallest non-outlier point. Well, I didn't have any low outliers, remember? So my smallest non-outlier point is 3. So I'm going to draw a line from my box to 3. So there's my lower line. We call that a whisker, actually. Then I'm going to do the same thing on the other side of the box. So I'm going to draw a line from the top of my box to my largest non-outlier point. So looking at my data set, the biggest point that was not an outlier is 15. So my line is going to go from the top of the box to 15. There we go. All right, and now all that's left is to represent my outliers. So to do that, I'm just going to draw an asterisk for, I only had one outlier in this case, so I'm going to draw an asterisk for 35. And there you have it. There is a box plot of my data representing the 5-number summary. And we can use box plots to figure out what the 5-number summary is too, if we have that. And again, remembering that each part of this box plot contains 25% of the data. So this lower whisker part, there's 25% of the data. The bottom part of the box is 25% of the data. The top part of the box is 25% of the data. And then this upper whisker and including that outlier is the top 25% of the data.